multiple choice questions. Question 1. Solution of two compounds W and X react together in the presence of a soluble catalyst Y as shown in the equation 2W plus X arrow Z. When the concentrations of W, X and Y are doubled, the rate of reaction increases by a factor of 4. Which is a possible rate equation for this reaction? Let's think about it. So obviously we're going to have this, right? Now it says when the concentration of W, X and Y are doubled, so that rate of reaction increases by a factor of 4. And that will give me 4. So that tells me we can't have a second order because it says the concentrations of all three of these are doubled. Rate of reaction increased by a factor of 4. So it can't be a second order because if it was a second order, 2 squared times by 2. Oops, all of a sudden that's not 4, that's 8. But it tells me the rate of reaction increased by a factor of 4. Okay, and then we're left with C and D. Now C says rate equals K, square brackets X, square brackets Y, and D says rate equals K, square bracket X, square bracket Z. Well, it can't be Z because that's the product. Rate equations are from the reactants, right? So it can't be D, therefore the answer must be C. And it makes sense. The presence of soluble catalyst Y. You know, just because it's not there, it's still going to be possible. So question 1C. Where's the next one? Question 2. Which graph would show that the reaction is second order with respect to D? Now we can already eliminate B and C because those clearly aren't second order. The first order, both of them. Now we're left with A and D. And second order with respect to X, but only the concentration of X was changed. The answer is going to be D. Question 3. Rate equals K square brackets A squared square brackets B. Correct units for the rate constant in the rate equation above are. They really like asking these type of questions, whereas multiple choice questions where like state the units of this. So all we have to do is rearrange it. So we get K equals rate divided by concentration of A squared divided by B. Now what are the units for that? Well, the units are rate is mol per dm minus cube s to power minus 1, and this is just going to be on the denominator mol per dm minus cube squared times by mol per dm minus cube, so therefore it's going to be mol per dm minus cube to power 3. What you notice, both of these two are the same, so that cancels out. So now we're left with s to power minus 1 divided by mol dm minus cube squared, which is mol to power 2 dm to power minus 6. But we want it in this format, not a fraction, and because these are denominator, we're going to do the inverse of that. So it's going to be s to power minus 1 mol instead of 2 minus 2 because it's denominator, dm instead of minus 6 can be plus 6. So we're left with that, and yeah, whichever one fits that. So in this case, all of them are s to power minus 1 at the end. That's probably the correct way to do it. So mol to power minus 2, dm to power 6, s to power minus 1. So the answer is D. Question 4. The rate equation for the hydrogenation of ethene is rate equals K square brackets C2H4 ethene square brackets H2 hydrogen. At fixed temperature rate of the reaction mixture is compressed to triple the original pressure. What is the factor by which the rate of reaction changes? Now, here's the thing. We've tripled the original pressure. We're trying to find the rate of reaction, how the factor by which it changes, by which it increases in this case. C2H4 and hydrogen, they're both gaseous, right? So if we're tripling the original pressure, what we're going to do to these? We're tripling these. So what actually is saying is it's saying that a C2H4 ethene, we're tripling that, and we're timesing that by hydrogen, which is tripled. So the factor by which the rate of reaction changes is just 3 times 3, which is 9. And yep, just spot that these two are gaseous state. That's why when we triple the original pressure, we're tripling them as well. And because both of them are first order, 3 times 3 is 9. Question 5. Okay. A rate investigation was carried out in a reaction involving 3 reactants, X, Y, and Z. The concentration of the reactions were varied, and the relative rate for each mixture was determined. The reaction is 0 order with respect to Y. What is the overall order of reaction? So we don't really care about Y because it's 0 order. And even if you do, let's say we've got X and Z as 1 and 1, for example, but 1 and 1 plus 2, 2 plus 0 is the same. It's 2. Okay. So what I would do is, because I know that the reaction is 0 order with respect to Y, let's look in between experiments 2 and 3. So we can see clearly by doing 5 times by 10 to the power minus 4 divided by 2 times by 10 to the power minus 3 increases times by 1 over 4. Y is 0 order, that's the same. Tells us, and Z, 4 times by 10 to the power minus 3 divided by 2 times by 10 to the power minus 3, and that is times by 2. Okay. And we know the relative rate goes from 4 to 0.5. So what we're doing is we're timesing it by 1 over 8. Okay, so we've got 1 over 4 times by 2. Is that equal to 1 over 8? No, it's not. It might look like it is because, yeah, we just do 4 times by 2, which is 8. It's not. That's equal to a half. Now, all I have to do is determine which order I need for either X or Z. Now, if it was a half, is a quarter squared times by 2, that would give me 1 over 8. So what would that tell me? Well, that tells me that X has to be second order, okay, squared. Z is first order, it's the same, and that will give me the rate of reaction as 1 over 8. And Y obviously is 0 order, so we don't, and it stays the same anyway, so I don't care about that. And that's the only way to get the rate of reaction as 1 over 8. You could, yeah, because you need a square term and a 1 term. So therefore, the overall order of reaction is just going to be 2 plus 1, which is 3. So the answer is D. Bit tricky, definitely a bit of a tricky question. I just need to, and question 6, this looks really tricky as well. It says this question is about the reaction between propanone and an excess of ethane-1,2-diol, the equation for which is given below. In the typical, now we can see here is a reversible reaction, it's at equilibrium. In a typical procedure, a mixture of 1 gram of propanone, 5 grams of ethane-1,2-diol, and 0.100 grams of benzene sulfonic acid is heated under reflux in an inert solvent. Benzene sulfonic acid is a strong acid. When the concentration of benzene sulfonic acid is doubled, the rate of reaction doubles. It can be deduced that A, the rate of the reaction is first order overall, and then you got those. So, okay, well, Now let's look at D. Let's try to eliminate that. If it is the correct answer, then obviously I know that's that and I don't really care about the rest. But if it's not, then I can eliminate one. The units for the rate constant K is that. Well, we know that obviously the rate constant is going to be these two. Ethane 1,2-diol and propanol. Yeah, propanol. And obviously we don't care about the products. So let's try to construct it. Rate equals K square brackets CH3CO CH3, and then it should be square brackets again, but on the space, square brackets HOCH2 CH2OH. Now if we rearrange that, we should get K equals rate divided by that. Rate is mole units mole per dm minus cube s to power minus 1 divided by, well, we've got one mole per dm minus cube, another mole per dm minus cube, so that's going to be mole per dm minus cube squared. And okay, and then that cancels out, and then we're left with s to power minus 1 divided by mole per dm minus cubed. So it's going to be s to power minus 1 mole to power minus 1 dm cubed. So it is actually not going to be D then in that case. The reaction is acid that's catalyzed. The reaction is first order overall. First order overall. That just doesn't make sense. How can it be first order overall? And it tells me when the concentration of benzene sulfonic acid is doubled, the rate of reaction doubles. Okay. To be honest, I'm not extremely sure for this one, so let's mark the rest, and then yeah, we'll go to that. So question 1 C, question 2 D, perfect. Question 3 D, question 4 B, question 5 D. I actually got that one right. And then question 6 C. The reaction is acid catalyzed. Well, that's just not really that relevant, you know. The units for rate constant, yeah, that's obviously wrong. I've clearly shown that. The reaction is first order overall. Clearly not. The reaction is third order overall. No, and the reaction is acid that's catalyzed. That's the correct answer. Reaction is acid catalyzed. And that is the end of the multiple choice questions.